Oh my God, I get to do all these videos all over again. It's so awesome. Unit 1 has like 30. There's 10 units. So we're going to probably be somewhere in the neighborhood like, 250 videos I get to create. Oh my God, it's so much fun. Anyway, I don't care. I'm having a good time. Anyway, this is going to be day 4 notes. Day 4 notes. Now, this stuff's not too difficult today, which is really good. My name is Mr. Kraus, but for the next half an hour or so, you can call me Mr. Answer Key. Remember, we're on day 4 notes, so hope you're in the right place. Okay. By the way, I don't know if I've mentioned this a number of times, but I know I haven't, but you can find all my stuff at, what in the world is that? www.mrkrausmath.com. And do me a favor, down here at the bottom of this YouTube video somewhere is a subscribe button. If you're using my stuff and I would really appreciate it if you just subscribe to my channel. That helps me out a little bit in the YouTube community, and I'm helping you out. So we're kind of helping each other. Okay. So let's talk about the absolute value function. The absolute value function, if you look at it, you're going to find out that it looks like a V. It looks like a V. But let's look and see how we do this on our graphing calculator. Okay. So we go into graph mode. Now, in order to graph mode, you're going to find the absolute value. It's going to be underneath this button right here. It's called the key of everything. It's right next to the 9. I click on the key of everything, and in that second row, sometimes it's on the first row, but usually it's on the second row. I click on that, and I just choose X. I don't know why I'm in caps mode. X. And it looks like a V. Right? Absolute value. So if you plug in a 1, you get a 1. You plug in a 2, you get a 2. You plug in a 3, you get a 3. You plug in a 4, you get a 4. Obvious. Plug in a -1, you get a +1. You plug in a -2, you get a +2. I can go look at the table. Control T. Right? Control T toggles that on and off if you've forgotten. All right, so we're going to go graph that thing. Now, I'm going to say this kind of a million times. A normal, without any transformation, a normal absolute value function, it hits the corners of the boxes. It's all the corners of the boxes. -1, 1, -2, 2, -3, 3, -4, 4. Unless it has a dilation. It's going to hit the corners of the boxes. Okay. This point right here is called the vertex. That's at the origin, 0, 0. The y-intercept is y equals 0 because it hits the y-axis, or right there at the origin. The domain, you'll notice that this goes forever and ever to the left and forever and ever to the right. Now the range is different, right? The lowest value is down here at 0, and the highest value is positive infinity. And because it equals 0, we'll put a bracket. Okay, so that's the absolute value function. This is the parent function for an absolute value function. Okay, so what we're going to do now is we're going to start, sorry, got to get more comfortable. We're going to just look to see what happens when I add some value to the end of this. In other words, we're going to just look at the original, and then we're going to add 2, add 5, and subtract 3. And I just want you to visually see what happens. All right, so I'm going to come over here, and I'm going to press Tab, and I'm going to do the same function, absolute value of X. But now I'm going to add 2. Now watch the graph. It's going to be in, I think red comes next. But you'll see the red graph. See what happens when I added 2. It shifted up 2. In other words, it took the vertex that was at the origin and shifted it up 2. Okay, let's do that again. Tab. And we're going to do the absolute value of X. And now I'm going to do +5. Oh, look at now. Now it's way up here. It moved from here up 5. And we're going to do one more. I think this one is -3. So tab. Why can't I do that? Tab. Absolute value of X. And then -3. And I think you all can envision that this is going to shift down 3. So when I add or subtract on the outside, in other words, outside of the absolute value, it is a vertical shift. In other words, up or down. And we're going to draw that picture in here. So when we got the 2, it hit the corners of the boxes. When I did the 5, oh man, like off, but it's going to go like this. And then when we down at -3, hits the corners of the boxes. Okay. Now what we're going to do is we're going to add on the inside. So what happens when we add on the inside of the graph? So we're going to use that same chart. Let me just do this. I'll keep that one. I'll get rid of this one for now. Oh, that's the one I want to keep. I don't want that one just yet. I don't want that one just yet. So let's go back. We got our original tab. But now what we're going to do is we're going to not add on the outside. We're now going to add on the inside, +2. Now, I think you guys can imagine what's going to happen. Should be pretty obvious what's going to happen, right? It's going to move to the right 2. Oops. I didn't check it. So it's going to move to the right 2. Oh, better graph that. It moves to the left 2. So it went here and then hits the corner of the boxes. That's weird. All right, let's go. Let's take a look at the next one. And did I use 5 again? Shoot. So now I'm going to add 5 on the inside here. Is it going to move to the left? Yeah, it moved to the left 5. So it moved, let me do that in a different color. It moved over here. 5. Well, what do you think is going to happen when we put the -3 in there? If the +3 moved to the left, then it would kind of make sense that the -3 moves it to the right. And we'll do that in blue or fuchsia, pink. Move that to the right. So when we add or subtract on the inside, I don't know why the arrow's there, inside, it is a horizontal shift. And that's left or right. But it's backwards. It's like the opposite of what you would normally think. So when you add, instead of thinking that it's going to go to the right, it actually goes to the left. Now when it's on the outside, it goes up and down like you would normally think. +5, +8, +6, +3, -2, -1. But if it's on the inside, it's backwards. And it's really kind of tricky. And you got to think about it. And the reason for it that is if you put in a -2, you get 0 out, right? That's what this would be, -2, 0. All right. What happens when you put a number on the outside? So let me go back. Let me just clear all. I'll start this all over again. Let me go back to my original. There it is. And now I want to put a number on the outside. So 2 times the absolute value. Oh, I keep hitting the wrong button. Absolute value of x. What's going to happen when I put a number on the outside? Watch the graph. See if it goes up or down. Oh, it didn't go up or down at all. It went from this to this. So in other words, it looks like it's changing how steep it is or its rate of change. Let's do one more. What was the other number I used? What was the next number I used? 5. Let's put a 5 out there. 5 times the absolute value of x. Oh, it got even steeper. So let me do that real quick. So what's happening is, and you're going to see it goes here, 2 and 2, and then 4 and 4, because that's being multiplied by 2. And then when you multiply by 5, it went up 5, and it got even steeper. Notice the rate of change is really drastically changed. It's getting much and much steeper. What happens when I put a 1/2 in front then? I think you know. I think it should be pretty obvious. If I put a half in front of there, I'm just going to put a 0.5 times the absolute value of x. It should be pretty obvious that instead of getting steeper, it actually gets wider. You know, if I put a 1/10 in there, 0.1 times the absolute value of x. Look how wide that gets, right? So if you put a fraction in front, 1/2 or 1/10, it gets wider. So that would look something more like, let's do purple, 1/2. But the vertex doesn't move. The only time the vertex moves is when you, that's the wrong point, add or subtract on the inside or outside. But when you multiply, it just gets steeper or wider. So this is a change of the slope. It gets narrower. How do you spell narrower? 2 R's. Narrower or wider. I'm going to say it changes the rate of change. What am I writing? Range. The rate of change goes up or down. It's going to change the rate of change is what it is. Well, that's weird. Change the rate of change. Why are all these little arrows all over the place? It's so weird. That's not the way they're supposed to be. I know it's because I changed the graphs here. All right, so what happens if we toss a negative in front? Now, I'm not going to change any of these graphs. I'm just going to hit the tab button. I'm going to go up. There's the originals in blue. Now, I'm going to uncheck all these just so you can see it. So I don't have to delete them. But now I'm going to go back up to that red one, and I'm going to throw a negative in front. I'm just going to get rid of the 2, though. I'm going to put a negative out front. Let's see what happens. Ooh, it went down. And then when I put a -5 in there, it goes, oops, I forgot to check it, put the check mark in, -5, it goes down but steeper. So tossing a negative in front, the negative is a reflection in the, or over the x-axis. And this, if you remember from Algebra 1, when you had a parabola that was going up, but as soon as I put a negative in front, it was a parabola going down. And we're going to do these transformations over and over again. So a negative in front is just a reflection in the x-axis. All right. So let's do a summary. The negative, that's a reflection. Let me pick a different pen. The pen's too fat. Is a reflection over x-axis. The A is really a dilation, which just means it's steeper or wider. When you add on the inside, and I want you to get in the habit of this because we're going to do this over and over again, these transformations over and over again. Inside, it's a horizontal shift. In other words, left or right. But backwards. The key thing about the inside is it's always opposite of what you think. It's backwards. And this is a vertical shift. This is a vertical shift. In other words, shift up or down. And that's just normal. So when it's on the inside, it's going to move left or right, but backwards from what you did. If I add on the outside, it moves up or down, normal from what you think. All right. So pause that if you need to, and hopefully you can read my writing or rewind it so that you can listen to what I'm saying to you. So all we're going to do here is take a look at what transformations took place on this function. So we see that we have no negative in front, so no reflection. We don't see a number other than 1 out front, so no dilation. But we do see an adding on the inside, so that is a I should have used these words a long time ago. That's a translation. Did I use those words in my... Yeah, I should have used those words instead of just simple words. I should have told you translation, because that's the... Anytime you have a movement, the word in geometry is translation. So this is a translation left 4 units. But we also have a -2 on the outside, so that is a translation down 2 units. All right, let's look at this one. Oh, what are the coordinates of the vertex? Now, so when we move, when we do the translations, what we're doing is we're actually moving the vertex. Let me go back over here. So when we move this, we're moving the vertex. When we move these, we're moving the vertex. So it's very, very simple. The normal place of the vertex is 0, 0. That's the normal place for the vertex. Now, if I take that 0, 0 and I move it 4 units to the left, it's now at -4. And I moved it 2 units down, -2. And that's the vertex. So what are we doing here? This is a translation. I'm going to combine these now. Translation, right 1, and up 3. Remember, this is -1, but we go right 1. It's opposite from what you think. So the normal vertex is at the origin. We're going to go right 1, up 3. So my new vertex is 1, 3. All right, so we have a negative out front, so that's a reflection over x-axis. We got a 2 out front, so that's a dilation factor 2. And I didn't leave you a lot of room, sorry about that. And we have a translation right 1 and up 3. So the right 1 and up 3 give you the new vertex, 1, 3. So I give you all that room to write the vertex and no room to write that. So now I want to write an absolute value function where this is the center. So normally the absolute value function looks like this. But we are going to move to the right 5. So that part goes there. So y equals right 5 is a -5. Remember, it's backwards. We also moved up 8. So plus 8. It's kind of just working backwards from these. Write an absolute value function. So we're going to y equals absolute value of x. Now we moved left 2. So we were here, we moved left 2. In order to move left 2, we have to add on the inside. We also moved up 3, so we're going to do plus 3. And y equals absolute value x. We moved left 7, so plus 7, and down 2, -2. That's all there is to that. All right. I think that's it. That's the end of day, what are we on? That's the end of day 4 homework. That's awesome. Awesome, awesome, awesome. Okay, hopefully you guys understood. I am going to go through the homework. If you haven't subscribed yet, please subscribe. All right, take care, guys. See you later. Catch you on the flip side.